Imagine a baby learning to walk. She stumbles, she falls, but she gets up and tries again. Each attempt teaches her something. She learns to balance, to coordinate her steps. Eventually, she's walking, running even. This, my friends, is learning from experience. It's how humans have always learned. And now we're teaching machines to learn the same way. This exciting new field is called reinforcement learning. Reinforcement learning is changing the game. Self-driving cars, learning from experience, robots in factories, learning on the job. This technology is poised to revolutionize our world. So buckle up. Let's explore the fascinating world of reinforcement learning together. Reinforcement learning is like training a dog. You give the dog a treat when it does something good, like sitting on command or fetching a ball. The dog learns to repeat actions that lead to rewards. Reinforcement learning teaches machines in a similar way. We don't program every single step. Instead, we create an environment. And we let the machine learn by trial and error. The machine receives rewards for good actions and penalties for bad ones. Over time, it learns the best strategy to maximize its rewards, just like our furry friends. It's all about learning from experience, making decisions, and getting better over time. That's reinforcement learning in a nutshell. In the world of reinforcement learning, we have a few key players. These players are essential for the learning process to unfold. First, we have the agent. The agent is our learner, the entity that is trying to achieve a goal. It could be a robot, a software program, or even a virtual character in a game. The agent is the one making decisions and taking actions. The agent interacts with its surroundings. It takes actions and learns from the consequences. This interaction is crucial for the learning process. Next, we have the environment. The environment is the world in which the agent operates. It provides the context for the agent's actions. It could be the real world, like a city street filled with autonomous vehicles, or it could be a virtual world, like a maze in a computer game. The environment provides feedback to the agent. This feedback comes in the form of rewards or penalties, guiding the agent's learning process. Then we have the reward. The reward is a positive signal. It tells the agent that it did something right, reinforcing good behavior. Rewards can be anything that the agent finds desirable, like points in a game, money in a simulation, or even just a virtual pat on the back. These rewards motivate the agent to perform better. Finally, we have the policy. The policy is the agent's strategy. It's a set of rules that determine the agent's actions in different situations. The policy guides the agent on what actions to take to achieve its goals. It's like a roadmap for decision-making. The agent's goal is to find the best policy, the one that maximizes its rewards over time. This continuous improvement is the essence of reinforcement learning. Remember that baby learning to walk. It's a fascinating process to observe. That's a perfect example of reinforcement learning in action, unfolding right before our eyes. The baby is the agent, constantly learning and adapting. The living room is the environment, filled with obstacles and opportunities. The reward, the joy of movement, the encouragement of proud parents, and the thrill of new experiences. And the policy, the evolving strategy of balance and coordination, improving with each step. But reinforcement learning isn't just for babies or simple tasks. It's being used to solve real-world problems. Take self-driving cars, for instance. The car is the agent equipped with sensors and algorithms. The city streets are the environment, bustling with activity. The reward, reaching the destination safely and efficiently without incidents. Penalties, traffic tickets, collisions, or getting lost along the way. Through trial and error, the car learns to navigate the complex world of traffic, avoiding obstacles and making decisions. Or consider robots in factories, tirelessly working on assembly lines. The robot is the agent, programmed to perform specific tasks. The factory floor is the environment, filled with machinery and tools. The reward, successfully assembling products with precision. The penalty, damaging parts or slowing down production, leading to inefficiencies. Through reinforcement learning, robots can learn to perform complex tasks with speed and precision, optimizing the entire process. Section 5, learning through trial and error. So how does reinforcement learning actually work in practice? It all starts with exploration. The agent needs to try different actions to see what happens and gather data. It's like trying different paths in a maze, figuring out which way to go. Some paths lead to dead ends, while others lead closer to the goal, providing valuable feedback. As the agent explores, it learns from its mistakes and successes. It remembers which actions led to rewards and which actions led to penalties, creating a mental map. This information is stored in something called a Q table, a crucial component. Think of it like a cheat sheet that the agent can refer to when making decisions, guiding its choices. Over time, the agent's Q table becomes more accurate and reliable. It learns the best actions to take in different situations, optimizing its behavior. This process is called exploitation, where the agent uses its knowledge. The agent is now exploiting its knowledge to maximize its rewards, achieving its goals more efficiently. Section 6. Reinforcement learning in action. Reinforcement learning is everywhere. It's powering recommendation systems, personalizing your Netflix queue, and suggesting products you might like on Amazon. It's optimizing traffic flow in cities and improving energy efficiency in buildings. In healthcare, reinforcement learning is being used to develop personalized treatment plans and to assist doctors in making diagnoses. In finance, it's being used to develop trading algorithms and to manage investment portfolios. The possibilities are truly endless. As we continue to develop and refine reinforcement learning algorithms, we can expect to see even more innovative applications in every aspect of our lives. Section 7. The future of learning. Reinforcement learning is still a young field, but it's rapidly evolving. Researchers are developing new algorithms that are faster, more efficient, and more capable than ever before. We're on the cusp of a new era of artificial intelligence. Imagine a future where robots work alongside humans, learning from our expertise and adapting to our needs. Imagine machines that can solve complex problems that have stumped even the brightest minds. This is the promise of reinforcement learning, to create machines that can learn, adapt, and evolve just like us. Section 8. Conclusion. We've journeyed together through the exciting world of reinforcement learning. We've learned how machines can learn from experience, just like humans. We've explored the key concepts of agents, environments, rewards, and policies. And we've seen how reinforcement learning is being applied to real-world problems. This technology has the potential to revolutionize our world, from self-driving cars to personalized medicine. Reinforcement learning is ushering in a new era of intelligent machines, machines that can learn, adapt, and evolve, and that's something to